So in this video, we're going to talk about how to solve 3x3 systems of linear equations using Gaussian elimination. So today we're going to continue learning how to solve systems that look like this. So remember, we've talked about how to solve these 3x3 systems algebraically and using matrices with Cramer's rule. In this video, we're going to learn a third method called Gaussian elimination. So the purpose of Gaussian elimination is to simplify a 3x3 system so that it's easier for us to solve algebraically. Because if you remember, when we were solving these systems algebraically, we had to perform a lot of steps. So Gaussian elimination is going to help simplify the system first before we get to doing the algebra. So what we're going to need to do is use row operations to transform our augmented matrix into row echelon form, which is abbreviated REF. So a matrix in row echelon form looks like this matrix right here. Notice that what happens is we have this corner of 3 zeros, right? So this is like a triangle of zeros in the bottom left of our matrix. And also notice that the last entry in row 3 is 1. So just to remind you, these are row operations that we're allowed to perform on an augmented matrix to transform it to row echelon form. So we can do row switching, multiply a row by a non-zero number, or multiply a row by a number and then add it to another row. So the reason we're doing this is so that we can get a simpler system of equations. So if I go backwards here, right, so I have my matrix in row echelon form, and if I write this out as a system of equations, remember column 1 represents the coefficients of x, column 2 will represent the coefficients of y, and column 3 tells us all the coefficients of z. So now let's think about how we'd write out these equations. So row 1 tells us we have the equation 2x plus y minus 4z equals 7, which we've written here. If we look at row 2, notice that our coefficient of x is 0. So we actually will not have an x in this equation. We'll just have 1y plus 2z equals 11. And then in row 3, our x and y have coefficients of 0, so we'll just have z equals 3. So that's the system that I've written here. And notice that if we think about solving the system algebraically, it's going to be much simpler to solve than this original system that we had. So that's the purpose of using Gaussian elimination first. So I know I keep showing you this example, but you may be wondering now, how did I go from this augmented matrix to row echelon form? And I told you that the answer to doing this was row operations, but how did I do these row operations and what was the sequence of them? So what we're going to do now is we're going to learn how that works. So, there's no specific rules on how to do this, but there's some general things that you'll learn as you do more problems that you'll want to keep in mind to make this whole process a little bit easier. So one thing that I like to do is I like to focus on making my 2 zeros in column 1 first, because it's sometimes hard to look at a matrix and figure out where to start. So if I start off by telling myself, okay, I need to form those 2 zeros before I do anything else, it helps me keep a little bit more organized. Because it can be overwhelming if you look at all the numbers all together and try to focus on making it into row echelon form all at once. So try to do like one goal at a time, and it just helps make the process a little bit easier. Okay, so I'm going to study my values in column 1 and see what I'm going to do here. So I have a 2 and 2, so I think it may be a good idea to get one of these 2's to cancel another 2 out. So in order to do that, I'm going to do negative R1, and I'm going to add it to R2. Okay, so remember, when I write down my new matrix, I'm going to write down the rows that don't change first. So row 1 is not going to change. And remember that row 3 is not going to change, so I'm just going to copy them down. Okay, so now let's think about what negative R1 is going to look like. So negative R1 will be negative 2, negative 1, positive 4, and negative 7. So now let's add these values to the elements of row 2. So we have negative 2 plus 2, which is 0, 4 plus negative 1, which is 3, 2 plus 4, which is 6, and 40 plus negative 7, which is 33. Okay, so now I'm looking at my matrix and thinking about what to do next. So one thing you always want to be on the lookout for is if you have a GCF of any of your rows. So if you have a GCF in a row, it's a good idea to go ahead and factor it out because sometimes it's helpful to have your rows in simplified form. So for example, I was just writing down the elements of row 2, and I noticed that they're all divisible by 3. Okay, so the way to divide by 3 is to multiply by the reciprocal. So I'm going to do 1/3 times row 2. Okay, and that's going to be the same effect as dividing every element by 3. So I'm going to start off by copying down row 1 and row 3 because they're not going to change. So I have 6, -2, 4, and 44. And then I have 0. 3 times 1/3 is going to be 1. 6 times 1/3 will be 2. And 33 times 1/3 will be 11. Okay, so now I need to figure out how to make my second 0 in column 1, right? So I have a 6 and I have a 2. So if I turn this 2 somehow into a -6, then I can cancel out this 6 down here. So the way to do that is to do -3 times row 1 and then add it to row 3. So that's exactly what I'm going to do. So remember, in this process, row 1 and row 2 are going to stay the same. So I'm going to go ahead and copy those rows down. And now let's think about what -3 row 1 is going to look like. Okay, so 2 times -3 will be -6. 1 times -3 will be -3. -4 times -3 will be 12. And 7 times -3 will be -21. So now let's go ahead and add those values to the elements of row 3. So 6 plus -6 is going to be 0. -2 plus -3 is going to be -5. 4 plus 12 is going to be 16. And 44 plus -21 will be 23. So now we have the 2 zeros that we needed in column 1. So let's continue simplifying this matrix. Okay, so now we need to get the 0 as our second element of row 3. So I have a -5 there, and I'm thinking about how to cancel this -5. Well, I have two possibilities, right? I could multiply row 2 by 5 and add it to row 3, or I can multiply row 1 by 5 and add it to row 3. So there's going to be a reason that I pick row 2, and the reason is because I never want to undo any work that I did, okay? So we want this first element of row 3 to be 0. If I multiply row 1 by 5 and add it to row 3, I'll get a 0 as my second element, but I'll undo this 0 that I made here, right? Because 2 times 5 will be 10, and then 10 plus 0 will give me a 10 right here. So that's how you kind of, strategize these row operations. You want to do them in a way that'll lead you to row echelon form while not undoing any work that you did. Because if you undo work that you did, you'll keep going in circles and then it won't really get anywhere. So that's why I'm going to choose row 2. And so I'm going to do 5 row 2 and then add it to row 3. Okay. So in this process, row 1 and 2 are going to stay the same. So I'm just going to copy them down. And now let's do 5 times row 2. Okay, so 5 times 0 will be 0. 5 times 1 will be 5. 5 times 2 is 10. 5 times 11 is 55. So now let's add these to the values of row 3. So we have 0 plus 0, which is 0. -5 plus 5, which is 0. 16 plus 10, which is 26. And 23 plus 55, which is 78. Okay, so now we're almost there, right? We have our corner of zeros that we needed, but we need to get this final element of row 3 to be a 1 before we can be fully in row echelon form. So the way to do that is, you see I have a 26 here, and I just need to get that 26 to turn into a 1. Well, I can just multiply by the reciprocal of 26. I can multiply by 1 over 26 in R3, and that's going to help me turn that 26 into a 1. So once again, I'm going to copy down row 1 and row 2 because those are not going to change. And now let's do 1 over 26 times row 3. So 0 times 1 over 26 is 0. Once again, we have another 0. And then 26 times 1 over 26 gives me that 1 that I needed. And then 78 times 1 over 26 is basically 78 divided by 26, which is 3. Okay? And that's how we get this augmented matrix that we had here, this matrix P, into row echelon form. So just like what I was saying as we were solving the problem, just some tips to keep in mind for Gaussian elimination. It's a good place to start by trying to make the two zeros in column 1. And even if they're in the wrong position, it's okay because you can always use row switching to move them to the bottom rows. Okay, so for example, if you had gotten a 0 as your first entry in row 1, that's okay because you can always fix that. Remember to always, look out for GCFs, and you can factor them out by multiplying by 1 over the GCF whenever you can. So for example, if all the elements in a row are divisible by 2, just multiply the row by 1/2 to simplify it. And also remember not to undo any zeros you've already made with row operations. So here's how we're going to do all of this all together. Okay, so how are we going to completely solve a system using Gaussian elimination? So we're going to first make sure all our equations are in standard form, then set up the augmented matrix to represent the system. Then we'll transform the augmented matrix to row echelon form using row operations, and then we're going to write the simplified system of equations. Using back substitution, we're going to then solve this system, and finally write our solution as an ordered triple. So what do I mean by back substitution? So we've done the first half of this problem, right? We already have the augmented matrix that we've transformed to row echelon form. And then we said, well, based on this row echelon form, we can write this system of equations. So now we're going to use a technique called back substitution that's going to allow us to solve for the variables, right? Because that's the ultimate goal. We want to know what x equals, what y equals, and what z equals. So here's my system of equations that we've figured out. And so what back substitution means is you can see here I already have the value of z. So I'm going to take this value and plug it back into the second equation. So that's going to give me this equation, right? I have y plus 2 times 3 equals 11. And that's basically y plus 6 equals 11. And now I can solve this equation for y by subtracting 6 from both sides. So when I subtract 6 from both sides, that's going to give me y equals 5. Well, now I'm going to take this y and this z, and I'm going to plug them both into this first equation. So when I plug them into the first equation, I get 2x plus 5 minus 4 times 3 equals 7. So I have 2x plus 5 minus 12 equals 7. So 5 minus 12, well, that's going to be minus 7. So I have 2x minus 7 equals 7. And I can now solve this by adding 7 to both sides. So when I add 7 to both sides, I'm going to get 2x equals 14. And then I'm going to divide both sides by 2. And that gives me x equals 7. Okay, so let me write my solution now as an ordered triple. So I have 7, 5, 3 as the solution to the system of equations. So that's how we take all of this and put it all together to solve the system of equations. So now let's try an example where we go through and completely solve using Gaussian elimination. So for reference here, I've written out kind of like a template of row echelon form just to remind you of where the zeros and the 1 are supposed to be. That's kind of like our goal, right? Whenever we're solving these problems. Okay, so remember step 1 is always to write out the augmented matrix, right? Once our equations are in standard form. So what I like to do is I like to add in those coefficients of 1 that are not written there because that's helpful when you're writing out the matrix. Okay, so the matrix for this equation is going to be 1, 1, 1. And then here we have 6. Okay, row 2 is going to be 2, 4, negative 1, 7. And row 3 is going to be 2, negative 4, 2, 0. All right, so always take a second to strategize before you start doing row operations. I want to get my 2 zeros in column 1 first, okay? So once again, I have those 2 2s, so I'm going to use a 2 to cancel another 2. So I have negative R3 plus R2, okay? If you want to do this the other way, if you want to do negative R2 plus R3, by all means, go ahead and do so. This is not an exact science, it's just that we can only use those 3 specified row operations and we want to work to getting in row echelon form. Those are the only rules. Okay, so now let's go ahead and copy down row 1 and row 3 because those are not going to change. And now let's do negative row 3. Okay, so negative row 3 is going to be negative 2, positive 4, negative 2, and 0. And now we're going to add those values to the elements of row 2. So 2 plus negative 2 gives us 0. 4 plus 4 is 8. Negative 1 plus negative 2 is negative 3. And 7 plus 0 is 7. Okay, so we have 1 0 in column 1. So now let's get our second 0. So I'm going to go ahead and do negative 2 times row 1 and add it to row 3. So that means row 1 and row 2 are staying the same. So I'm going to go ahead and write those down first. And now let's write row 2. So we have 0, 8, negative 3, and 7. Okay, so let's do negative 2 row 1 and see what that looks like. So 1 times negative 2 is negative 2. So I'm going to have negative 2's for my first 3 entries. And then 6 times negative 2 is going to be negative 12. So now let's go ahead and add the elements of row 3 to these values. So we have 2 plus negative 2, which is 0. Negative 4 plus negative 2, which is negative 6. 2 plus negative 2, which is 0 again. And 0 plus negative 12, which is going to be negative 12. So notice here that I can actually go ahead and simplify row 3, right? I can actually divide this whole row by 6. And as a matter of fact, since both of these are negative, I'm going to multiply by negative 1/6, okay? And so negative 1/6 row 3 is going to transform this matrix, and it's going to turn into, let's see, we have 1, 1, 1, 6, and we have 0, 8, negative 3, 7, and then we have 0, right? 0 times negative 1/6 is still 0. Negative 6 times negative 1/6 will become 1. 0 again, and then we have negative 12 times negative 1/6, which is going to give us positive 2. Okay, so we have our 2 zeros in column 1, but when I'm comparing to row echelon form, I notice this issue in row 3. So here I have a 0, but I actually want the last entry of row 3 to be able to at least turn into a 1. Okay, so I need to fix this, but I don't want to undo any work that I did. So I think the quickest way to do this would be actually to move row 2 down here to row 3, okay? That way I still have that 0 as my first entry, and then I can, somehow down the road I can turn this negative 3 into a 1. So I'm going to go ahead and use my row switching. So I'm going to switch row 2 and row 3. So when I do that, it gives me this matrix. I have 1, 1, 1, 6. And then I have 0, 1, 0, and then 2, and then 0, 8, negative 3, and 7. Okay, so now let's work on getting our 0 in column 2. So remember, I want this last entry in column 2 to be a 0. So I think the quickest way to do that would be to multiply this row 2 by negative 8. So I'm going to go ahead and do that. I'm going to do negative 8 row 2, and then I'm going to add that to row 3. Okay, so every row is going to stay the same except for row 3. So I'm going to go ahead and copy down those rows. And let's see, we have 0, 1, 0, 2. And so now let's see what negative 8 row 2 is going to look like. So we have, 0. 1 times negative 8 will be negative 8. 0 again. And then 2 times negative 8 will be negative 16. So let's go ahead and add these values to row 3. So 0 plus 0 will be 0. 8 plus negative 8 will be 0. Negative 3 plus 0 will be negative 3. And 7 plus negative 16, that's going to be negative 9. Okay, so we're almost there. We're almost in row echelon form because we have this triangle of zeros here. But we now need to turn this negative 3 into a 1. Okay, and the quickest way to do that is just to multiply by the reciprocal of negative 3. So that reciprocal will be negative 1/3. And so I'm going to multiply my row 3 by negative 1/3. Okay, so my row 1 and row 2 will stay the same. So I have 1, 1, 1, 6, and I have 0, 1, 0, 2. And that's going to give me 0, 0. And then I'm going to do that negative 3 times negative 1/3. And that'll be 1. Okay, and then my final entry would be negative 9 times negative 1/3. So that's going to be 3. Okay, so now my matrix is in row echelon form. But remember, we're still trying to solve this by Gaussian elimination. Okay, so we're not done yet. What we need to do now is write our system of equations. So this first column is going to be x, my second column is going to be y, and my third column is going to be z. So let's write out our system of equations. So the first row right here, all of these 1s and 6 gives me the equation x plus y plus z equals 6, right? 1x plus 1y plus 1z equals 6. Okay, the second row, well, that gives me the equation y equals 2, right? Because my x had a coefficient of 0, z has a coefficient of 0. And then now this third row gives me the equation z equals 3. So actually it worked out nicely in this problem because when I did Gaussian elimination, it actually helped me solve for 2 variables. So all I need to do now is plug both of these back into the first equation, and that's going to let me solve for x. So I have x plus 2 plus 3 equals 6. Okay, so that's going to be x plus, well, 2 plus 3 is going to be 5, and that's equal to 6. So now to solve for x, I just subtract 5 from both sides. And so that's going to give me x equals 1. So if I write my solution as an ordered triple, it's going to be 1, 2, 3. All right, so let's try another example. So now let's try solving the system. So I have my row echelon form here for you to reference. Remember, I like to start off by adding in my coefficients of 1, because that's going to help me out when I write my augmented matrix. So my augmented matrix is going to look like 2, 1, -1, 7. Then row 2 will be 1, -3, -3, 4. And then 4, 1, 1, 3. Okay, remember, always take a second to strategize before you go ahead and solve these problems. So I want to get 2 zeros in column 1. So I think one way to get a 0 would be to do -2r2 and then add it to r1, right? Because I have this 1 right here, and it's really actually helpful if you have a 1 because you can get it to cancel out a lot of things. Okay, so when I do this, row 1 is going to change, so I'm going to copy down row 2 and row 3 because they're going to stay the same. So 4, 1, 1, 3. Okay, let's think about now what -2r2 will look like. So 1 times -2 is -2. -3 times -2 is 6. -3 times -2 is 6 again, and then 4 times -2 is -8. So now let's add these values to the elements of row 1. 2 plus -2 will be 0. 1 plus 6 will be 7. -1 plus 6 will be 5. And 7 plus -8 will be -1. So now let's think about what to do next. So I need to make a second 0 in the first column. So I'm going to use that 1 in row 2 to help me out again. So I'm going to do -4 row 2 plus row 3. So remember, when I do this, my row 3 is going to change, but my row 1 and row 2 are going to stay the same. So I'm going to write those down first. And so that gives me this matrix. I have 1, -3, -3, 4. And so now let's figure out what -4r2 looks like. -4r2 is going to be 1 times -4, which is -4. -3 times -4, which gives us 12. And then we have 12 again. And then we have -4 times 4, which is going to be -16. So now let's add those to the values in row 3. So we have 4 plus -4, which is 0. 1 plus 12, which is 13, and 1 plus 12 again, so another 13, and 3 plus -16, which gives us -13. So as I was writing this row down, I noticed that I wrote 13 several times. So I'm going to actually go ahead and divide that entire bottom row by 13. And remember, I can do that by multiplying the whole row by the reciprocal of 13, which is 1 over 13. So I'm going to do 1 over 13 row 3. And so my row 1 and row 2 are going to stay the same. So I'm going to go ahead and copy those down. So 1, -3, -3, and 4. And then so now we do 0 times 1 over 13, so that's just going to be 0. And then 1 over 13 times 13, which will be 1. And then we have 1 again. And then 1 over 13 times -13 is going to be -1. Okay, so now I have 2 zeros in column 1, but when I look at row echelon form, I need those 2 zeros to be at the bottom. okay? But that's a problem we can easily fix. We can just use our row switching to correct this. So I'm going to now switch row 1 and row 2, and so that we can move that 0 down. So when we do that, row 1 is now going to become 1, -3, -3, and 4. And row 2 will now be 0, 7, 5, -1, and then we have 0, 1, 1, -1 for row 3. So now I'm going to look at my row echelon form to see what I need to do next. So now what I need to do is work on making this 0 in column 2. So if I look at my values in column 2, I think it's going to be easiest to turn that 7 into a 0. And I can do that by multiplying row 3 by -7 and then adding it to row 2. So when I do that, remember my row 1 and row 3 are going to stay the same. So let's go ahead and write that matrix now. So my first row will be 1, -3, -3, 4. And my last row will be 0, 1, 1, -1. So remember, in this case, I need -7 of R3. So I'm going to go ahead and do -7 times R3. So that's 0, -7, -7. And -1 times -7 is just going to be +7. So now I'm going to take all those values from row 2. So remember that was 0, 7, 5, -1. I'm just going to write them down here with my scratch work so you know what I'm talking about. And then I'm going to add these values together. So that's going to be my row 2 now. So I have 0, -7 plus 7 is 0, -7 plus 5 is -2, and 7 plus -1 is going to be 6. So now let's go back and look at our row echelon form to see where we're at. Well, notice in row echelon form, I have 1 0 in row 2, but then I have those 2 zeros in row 3. So really this matrix would be a little bit better if I went ahead and switched these two rows. Okay, so I'm going to go ahead and do that next. I'm going to switch row 2 and row 3. And so that's going to give me this new matrix, 1, -3, -3, 4. And now my row 3 will become row 2. So I have 0, 1, 1, -1. And I have 0, 0, -2, 6. Okay, so I'm almost there, almost in row echelon form. I just need to make this last entry in row 3 equal to a 1. And remember, I can do that by multiplying by the reciprocal of that number. So I'm going to multiply by the reciprocal of -2, which is -1/2. And I'm going to do that to row 3. So when I do that, my new matrix will be 1, -3, -3, 4, and then I have 0, 1, 1, -1, and then I have 0, 0. Well, -2 times -1/2 is going to be 1, and then 6 times -1/2 is going to be -3. So now finally I have my matrix in row echelon form, so I can go ahead and write my system of equations. So let's write our first equation. So that's going to be x minus 3y minus 3z equals 4. My second row is going to give me my second equation. So I have no x. I have y plus z equals -1. And then my last row, so I have 0x, 0y, and then 1z. So that z is going to equal -3. Now let's go ahead and do our back substitution so we can figure out the other values. So z equals -3 gets plugged in here. So I have y plus -3 equals -1. Well, y plus -3 is basically y minus 3. So y minus 3 equals -1. I'm going to go ahead and add 3 to both sides. And when I do that, that's going to give me y equals 2. Okay, so now I'm going to take my y equals 2 and my z equals -3 and plug into my first equation. So I have x minus 3 times 2 minus 3 times -3 equals 4. So that's x minus 6 minus 3 times -3, that's going to be plus 9, and that equals 4. And then my minus 6 plus 9 is going to become plus 3, so we have x plus 3 equals 4. And I can now solve this by subtracting 3 from both sides. And when I do that, that's going to give me x equals 1. Okay, so my solution as an ordered triple will be 1, 2, -3. Okay, so now let's try another example. So once again, I have my row echelon form written up here for reference. And let's go ahead and fill in those coefficients of 1 that are missing from our system of equations. So my augmented matrix that represents this system will be -1, -5, -5, and then 2. And we have 4, -5, 4, and 19. And we have 1, 5, -1, -20. Okay, so remember, first time we look at this matrix, we always want to be thinking about where can we make zeros in the first column, right? So we're thinking about that, and the nice thing is, notice that we have two values that are equal and opposite, right? We have a -1 and a 1, so I think I can go ahead and start working with that. So I'm just going to go ahead and do row 1 plus row 3, and that's going to help me make a 0. So my row 1 will stay the same, and my row 2 will stay the same. And now my row 3 is going to have all the values of row 1 added to it. So -1 plus 1 will give me 0. -5 plus 5 will give me 0. -5 plus -1 is -6. And 2 plus -20 is going to be -18. So that worked out really nicely because I not only made 1 0 in column 1, I also went ahead and got those 2 zeros I need in row 3, because you can see that's what I need in row echelon form. Okay, so now I still need to work on creating that second 0 in column 1, and I can do that by multiplying row 1 by 4 and then adding it to row 2. Okay, so when I do that, my row 1 is going to stay the same, so I'm going to go ahead and write that down. And also my row 3 is going to stay the same. So I'm going to go ahead and copy down row 3. Okay, so let's figure out what 4R1 will look like. So 4 times -1 will be -4. -5 times 4 will be -20. -5 times 4 is going to be -20 again. And then 2 times 4 will be 8. So let's add these values to row 2. So -4 plus 4 is going to be 0. -5 plus -20 is -25. 4 plus -20 will be -16, and 19 plus 8 will be 27. Okay, so now all we need to do to turn this into row echelon form is turn this -6 into 1. And remember, we can do that by multiplying by the reciprocal of -6. The reciprocal of -6 will be -1/6. I'm going to multiply that by R3. So I have my new matrix, so -1, -5, -5, 2, and then row 2 stays the same. I have 0, -25, -16, and then 27. And then my first two entries are going to stay 0. -1/6 times -6 is going to be 1. -1/6 times -18 will be 3. Okay, so now finally I have my matrix in row echelon form. So let's go ahead and write the system that corresponds. So remember, this column is X, this column is Y, and this column is Z. So we have -X minus 5Y minus 5Z equals 2. The second equation will be -25Y minus 16Z equals 27. And the third equation will be Z equals 3. So now let's go ahead and do our back substitution. So I'm going to take the Z equals 3 and plug it in here. So that's going to give me -25Y minus 16 times 3 equals 27, which tells me that -25Y minus 48 equals 27. And I can now solve this by adding 48 to both sides. So when I do that, I get -25Y equals 27 plus 48, which is 75. And now I'm going to go ahead and divide both sides by -25. And when I do that, I get Y equals -3. Okay, so I have Z equals 3, Y equals -3. And I'm going to go ahead and plug that into the first equation right here. So I have -X minus 5 times -3 minus 5 times 3 equals 2. So that's -X minus 5 times -3, that's going to become plus 15. And then minus 5 times 3 will be minus 15, and that equals 2. So I have -X plus 0 equals 2, which tells me that -X equals 2. So remember that a -X basically has a coefficient of 1. So to solve for X, I'm going to divide both sides of this equation by -1. So that's going to give me X equals -2. So let's go back and collect all of our variables. So we have X equals -2, Y equals -3, and Z equals 3. So our solution written as an ordered triple will be -2, -3, 3. So now you can go ahead and pause the video and try doing this example on your own. So here's my solution to this problem, but I want you to realize that you could have done the row operations differently and still gotten the same answer. So I chose to do negative row 2 and row 3 because, like I said, I'm trying to get those zeros to form in column 1. And so then I got the 0 in row 3, and then I went ahead and did negative 2 row 2 and added it to row 1. And so that gave me my second 0. Then, of course, I needed to do row swapping to get my zeros to come down to the bottom of the matrix. So after that, I went ahead and did negative 2R2 plus row 3 so that I could get this 5 to become a negative 10 so that it would cancel out this 10. So then once I did that, I did negative 1/2 row 3 because all I needed to do was turn this negative 2 into a 1 to get into row echelon form. So now this matrix is in row echelon form. Remember, this column tells me X, this column tells me Y, and this column tells me Z. So I have the system of equations negative 2x minus 5y minus 2z equals 12, 5y plus 3z equals negative 6, and z equals negative 2. So then back substitution in the second equation gave me y equals 0. And then I took y equals 0 and z equals negative 2 and plugged into the first equation to find x equals negative 4. So negative 4, 0, negative 2 is the ordered triple. That's the solution to this system. So remember, we can use an augmented matrix to help us solve a system of 3 by 3 linear equations. We can perform row operations to transform an augmented matrix to row echelon form, which helps us transform the system into one that's easier to solve using back substitution.